Hello everyone, welcome back to MGF1106. In this video, we will learn how to use diagram to represent a set and what kind of diagram we use to represent a set. Other than that, we also discuss about the concept of intersection and union. Whether or not we're going to have a set when we intersect two sets to each other, or we're going to make a union between two sets. Okay, so in this, let's start our section 2.3 over here. Okay, section 2.3. Okay, so the diagram we would be using to represent the set, we call that Venn diagram. Okay, Venn diagram. Okay, and intersection and a union between two sets, we call that set operation. Okay, set operation. Okay, so let's talk about Venn diagram first. So first part, Venn diagram. Okay, what is Venn diagram and what it look like? So this is the diagram which is invented by an English, a British mathematician, John Venn. So John Venn invented this type of diagram. Okay, John Venn. Okay, it's about 100 years ago. So he lived around 1834, and he passed away in 1923. So maybe about 100 years ago. Okay, and this guy used a rectangle, okay, and circle to represent set. And the rectangle here, so he used okay, rectangle, okay, and circle, and each circle in Venn diagram representing a set, and the rectangle in Venn diagram it used to represent universal set. So over here used to represent universal set, and the circle over here represent set. Okay, so we have a rectangle like this, so something like this. What if we have a rectangle? Okay, and this rectangle over here, it represents universal set. Okay, this is universal set, and in this universal set, because in the previous video we were talking about universal set. A universal set containing all elements that is discussed in the problem. So all the elements of the set, so the set is a part of universal set. So the set must be inside universal set over here. And let me say that the set over here is set A. So this is the circle over here represents set A, and set A over here is inside universal set. Okay, and sometime in universal set it can contain more than one circle. I mean, it can contain more than one set. It could be two set or three set. Think about it. The more circle, the more set you have in universal set, then later on when we do operation, it could be harder. Okay, and there are several ways to represent subset in the universal set. In this video, we will just talk about a case where we have two or three subsets in the universal set. Okay, in the diagram, and the first case is that when we have so case one. Okay, when we have a universal set. Okay, we have a universal set, and we inside the universal set over here, I draw two sets, okay, represented by circle, okay, okay. And over here I call this set A, and over here I call set B. And you see that this two set over here is not overlapping each other, so is it share anything in common. So these two set over here we call as the disjoint set. Okay, disjoint set. Yeah. So disjoint set is a set that does not share anything in common. So you see that it's all separate, and these two set over here is inside universal set. Okay, so whatever the element of set A and set B, this is just an element of universal set. Case 2. Okay, case 2 is when we have we have a universal set. Okay, we have a universal set. Okay, and in this universal set we have a set A. Okay, set A is this circle. Okay, set A is this circle, and inside set A we have a set B. Okay, this circle set B over here. So I can say that set A over here is set A over here. The set B over here is a subset. Okay, a subset of set A. Right, because this set B over here is contained inside set A. Okay, contained inside, and all the set over here is subset of the universal set. So A is subset of universal set, B is subset of universal set. Okay, that is case 2. Okay, when you see two set inside the universal set by using Venn diagram. And the third case is when we have case 3. Let's see. Okay, case 3. So I'm gonna write over here. Okay. So case 3, we also have two set. Okay. Okay, it's the universal set, and inside this universal set we have two set. And this two set over here is equal to each other. So the first is set A over here. Okay, is in a blue color, and set B over here is the same as set A. Okay, it's the same as set A. It's in orange. So these two sets are equal to each other. So the set A. Okay, set A. Okay, the set A over here is equal to set B. Okay, and both of them are subset of a universal set. Okay, equal set. So this is equal set. Okay, equal set. Okay, so that's the third case you may see. And the case number 4, when you have two sets inside universal set, and those two sets share something in common. So something, so we have an overlapping set. Okay, so we have again you have a subset like this. I'm sorry, we have universal set like this, and we have two different sets. Okay, and the first set over here. I'm going to use different color, so I'm going to have set A over here. Okay, and I have a set B over here in green. Okay, and you see that set A and set B over here, they share something in common between, right? So they share something over here in between. Okay, so they overlap a little bit over here, right there. So they share something in common. So later on, actually, this Venn diagram over here represents intersection concept, right? Okay. Okay. Of course, you may use the Venn diagram to display more than two sets. So in some cases, you probably see three sets overlapping each other, which is you probably see in the next couple section. The last section when you do application of the set, you may see three set overlapping each other. You may see something like this. Okay, something like that. Set A, set B, set C, and all of them over here contained in the universal set. You may see that case, okay? You may see that case. But in this code, you're not gonna see more than three sets. Okay, at most you can see only two or three sets only. Okay, so this is a very special case. Okay, so this could be, I'm gonna put over here as the case number 5. Okay, but in the textbook in the beginning of this section they did not mention this, but you might see that in the next in the last section of this chapter. Now let me start our first example here. Example number 1. Alright, so I have a Venn diagram like this given. Okay. Okay, let's draw a Venn diagram. Let's draw the rectangle big enough so that you can see clearly. Okay. Okay, this is universal set. And in this universal set over here, I have two circles. Okay, two circles. Okay. And these two circles represent set A and set B. And this circle, this set over here contains some element. Over here contain letter D, so that we use different color right here. Over here, you know what? I'm gonna draw this again. It's big enough so that you can see. Okay, so set A, set up like that, and make it set B bigger. There you go. It's not a nice circle at all. Let's trim it. Let's draw a little bit more carefully. There you go. It's a little bit better. And set it over here. They have 4 elements A, B, C, D. But it's A, B, C, and D is the element that share in common between two set A and B. And over here I have set E only. So set A over here has 4 elements and set B has 2 elements, and they both share the element as a common part between those two sets. Okay, and in universal set over here we also have element F and G. Okay, so the question for this example is this. Determine okay, universal set and set B. Okay, easy here. You just need to observe this picture and you can get the element out of it. Set A, determine set of element in A but not in B. Okay, C, set of element in U that are not in B. Okay, and B, set of element in both A and B. Okay, it's very easy. We just need to observe the picture and we can answer that. Okay, so universal set. Okay, we can find universal set. Universal set contain all the elements. So universal set we will have A, B, C, D, E, F, G. Okay, and set B. Okay, set B. You just see whatever element in set B. So B, D, and E. Okay, okay, that's part A. Set element in A but not in B. In A but not in B. So I'm going to call this set C. Okay. A but not in B. In A but not in B. Should be A, B, C. Okay. C. I'm going to call it set D. You just name whatever you want to set it in U, but that is not in B. In U but not in B. So except for D and E. So we have A, B, C, F, G. Okay. And finally, in both A and B. So there's just one element, right? So B. Okay. Very easy, right? You just need to observe the picture and you can get the element out of it. Okay. All right. Now, what if I want to find a set? Okay, I want to find a set that is not in A. Okay, if it is set that is not in A, okay. What if I have a set A? Okay, what if I have a set A? And the set A is inside universal set, and I want to find the set that is not in set A. Okay, the set that is not in set A but is still in the universal set, we call that complement set. Okay, so we can find a complement of set A. So complement of set A contain all the element that is not in A but in the universal set. Okay, so on the second part, okay, on the second part of this video, okay, we will be discussing set operation. Okay, and the first set operation we want to talk about is the complement of a set. Okay, of a set. You want to check the complement of the set. So the complement of the set is a set. So given set A, then complement of set A is notated as A prime. You know, in some textbook, they write like this: A and the bar. So this is also the complement of set A. So the complement of set A is a set. So complement of set A is a set, and this set over here, which contain all element in U, universal set, but not in A. There you go. There you go. For example, I have something like this. Whatever I have a universal set like this. Okay, I have universal set. Okay. Okay. And I have set A like this. I have over here 1, 2, 3, 4, 5, 6, 7. So you see the complement of A. Complement of set A is a complement set. It contains anything except for element inside A. So it will be 4, 5, 6, and 7. Okay. Okay, you can write like that. Very easy, right? Very easy. Just whatever the element that is not in there will be the complement of that. Let me give you a second example. Let me see, I can get another example right here. So what if I have universal set like this? Okay. And this is the universal set over here contain set A rallies. So they have Jack, King, and Queen. And outside here we have heart, spade, heart, and diamond. Okay. So the complement of set A will be a set including spade, okay, heart, and diamond. Okay, yeah. Now I have two sets, okay, and these two sets has some element in common, okay. Then those elements I can go ahead and create another set. We call the intersection set. So intersection set is a set, okay, intersection is a set which contain elements that share by two different sets. Okay, so on this the next operation I want to discuss here will be intersection set. Okay, so I'm gonna put here two intersection. Okay, so intersection is actually it just intersection means you find this element that share in common between two sets. Okay, so intersection literally mean share in common, okay, between two sets, and I can create a new set using those elements. Okay, so given set A and set B, so I can go ahead and find intersection between two sets, and the symbol for intersection could be A intersect B. Okay, A intersect B. So this intersection right here is a new set. Okay, so A intersection B is a new set. I'm gonna call it set C. Okay, so this set C over here containing all element in set A and set B. Okay, in set A and set B. Let's do example. Okay, example. What if I have a set A is let's say I have set A. I have a 7, 8, 9, 10, 11, 8, 9, 10, 11, and I have set B. Okay, it's 6, 8, 6, 8, 10, and 12. Now I can go ahead create a new set, intersection set between A and B. Okay, so we're gonna go ahead find the element of share in common. So between A and B, so will be what? Will be A, 10, right? A and 10. There you go. That's how you find intersection. Now, what if I find intersection between a set, and let's say I'm gonna have a set A here, 1, 3, 5, 7, 9. Okay, and I have a set B, and my set B is an empty set, and I want to find intersection set between these two. So what do you think? I have set A like this, and I intersect with an empty set. Empty set, it means there's no element inside. There's no element. So there's no element. And over here we have some element. So intersection means that there's nothing, right? So intersection between an empty set and a set is just an empty set. It's an empty set. Okay? So remember that intersection between a set and an empty set is just an empty set. Nothing else. So in some cases, okay, and when we find when we find intersection between two sets, for example, and this also gives you an empty set. For example, I have something like this. I have we set A is 1, 2, 3, and set B is 4, 5, 6, 9, and you see that there's nothing in common. So the intersection between A and B is also an empty set. There's nothing in common, so this is empty set. Okay, so that is the definition of intersection. Of course, later on we're gonna do more problem, but I think at this moment we just do 3 examples. I think that's good. It's just for you to understand what intersection means. Now the third operation, okay, I want to talk about, we call it union. We call it union. So union is like we just what to tell you everything, right? Union is mean you take everything, right? You have been to UCF. This is a building. We call it the student union. Student union where all the students will gather over there. They gonna have all different type of rest, and doesn't matter what your background. It doesn't matter what your major is. You just go over there and have some fun, and you can discuss about anything. Okay, so that's what union is. So union literally mean it means you take everything. You take everything. Okay, so you mean taking everything, taking all elements. Okay, doesn't matter the element is in set A or doesn't matter the element in set B. You just go ahead and take all the elements. That's what it means. Okay, that's what it means. Okay, and this is a mathematical definition of union. Okay, given as set A and set B. So the union between set A and set B is notated as A union B. Okay, A union B. So A union B is a new set. Okay, I'm going to call it set C. And this set over here contain element containing element. Okay, of set A or set B or both. Okay, so that's what it is. Back in the day, we call union is or, set A or set B. That is the concept we learn in college algebra. Maybe some of you have not learned college algebra, but that's what it is. In college algebra, we also have a union concept. So A union B, A union B is the collection of member element. I'm gonna put it in the set builder notation of X, and X is belong to A, or X belong to B. So it doesn't matter if it belong to A or it belong to B. It is just an element of union. Now, based on this set builder notation, I think we can use the set builder notation for the intersection also. So I can write A intersect B is the set containing X value from X to A and X belong to B. Okay, X belong to A and X belong to B. Okay. Now let me give you an example. Okay, whatever have this. What if I have a set A is 1, 3, 5, 7, 10, 5, 7, 10, and set B is 6, 7, 5, 6, 7, 9, 11. Okay, so I can find A union B. Okay, so we're gonna take all different element. If it is repeated, we just take one. So it doesn't matter it's in A or B, we take them all. Okay, but if it's repeated, we just take one. So we're gonna take 1, 3, 5, 6, 7, 9, 10, 11. There you go. That's how you find union. And now what if I have a set and I want to find union with empty set? What if I have set A? Again, the set A over here 1, 3, 5, 7, 10, and set B is an empty set. Okay, what do you think? I have union between A and B. What do you think? What it give you? What it give you? Well, this is the set B over here. There's no element, and this one has a 1, 3, 5, 7, 10. So your union means you take them all, right? With no element or this. So at the end, we're gonna have 1, 3, 5, 7, and 10. Here you go. That's how you find union between empty set and a certain set. Okay, very easy, right? Just take all of them. Okay. Let's see what else. So we already talked about union. We talk about intersection. Okay. Let's see. We can go ahead and combine all the concept we learned so far: union, intersection, complement. Let's see if we need to do something else before we do some practice regarding to union, intersection, and complement at the same time. Let's see. Okay. Oh, let's talk about the difference of set first. So on the fourth operation here. Okay, operation. I would like to discuss the difference between two sets. Okay, difference between two sets. Okay, maybe we're gonna do more practice problem later. Okay. Cannot draw even a straight line, sorry. Even between two sets. Okay. Okay. Alright. Now given two sets. Okay. I'm sorry. Given two sets. Set A and B. Set B. Okay, given two set A and B. Then the difference between two sets is notated as simple as difference between two sets is simple as notated as A minus B. Okay, difference mean minus. But what does it mean by A minus B? A minus B, it mean that, which mean, so the difference between two sets is a set. Okay. Okay, it's a set. Okay, so I'm gonna call which is a set over here, and which mean the set, okay, containing element in A but not in B. There you go, that's what I mean. So the difference between two sets is a set. The intersection between two sets is a set. The union between two sets is a set. The complement of a set is also a set. So all of it is just a set. And the set, in this set over here, the different set over here is a set contain all the element in A but not in B. Now let me give you an example. Let's see here, example. Okay, example number 1. Okay. Now what if I have something like this? I have a universal set. Okay, universal set like that. And this is the universal set over here. I guess I might just need to give you one example. That's good enough. Too many is not good. And this is the universal set here. Contains some element A, B, C, D, E, C, D, E, F, G, okay, H, I, J, K. Alright, so there's a bunch of elements over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11. Okay. And we also give you set A. And set A over here is BD, E, F, G, H, E, F, G, H. Okay. And set B over here is A, B, D, A, B, D, H, I. Okay. And set C over here is B, E, G, B, E, G. Okay. So the question over here is find the set difference between A and B. Okay, find set A minus set B. Find A minus C. Complement of A minus B. Okay, and A minus complement of C. Alright, let's see how we do that. Okay, that's the question. Alright, answer. Let's do A minus B first. So in A but not in B. In A but not in B. Okay, so in A but not in B. In A but not in B. So over here it should be E, right? E, F. You see, you compare A but not in B, in A but not in B. So E, F, G. Okay, E, F, G, right? Okay. Okay. How about part B? In A but not in C. Okay, in A but not in C, A not in C, so B have it. It should be D, F, D, F, and H. Alright, see that? Just look, just observe. Complement of A and B. So in the complement of A, okay, but not in B. So first of all, we need to find the complement of A. So complement of A, which is we compare it with the universal set, whatever outside A. So it should be what? Should be A. C. We have AC. F over there, G over there. So we have G. H over there. We have I, J, K. So I, J, K. Now J, K is in universal set, but it's not in A. So it's a complement of A. Then we compare this. Okay. Comparing to set B, which is in this but not in B. So we're gonna end up with set complement of A minus B will be in complement of A but not in B. So should be B. So should be C in A prime but not in B. So should be C. I have it. J and K. Right? C, J, K. Okay, very easy, huh? And finally, we want to find a set that in A but not in the complement of C. So we need to find the complement of C first. Complement of C. So B, E, G. So B, E, G right here. So the complement of C will be A, C, D, F, H, I, J, K. There you go. Then we're gonna go ahead and compare that. Comparing to A. So in A but not in C prime. So at the end we're gonna have A C prime will be in A but not in C prime. So C prime it is, so in A but not in C prime, so be B, right? B E G B E, right? And G B G. There you go. Very easy, huh? Very easy. Okay. So in order to go ahead and express this, displace this on the Venn diagram, it's gonna take a little bit time because we have over here we have three elements. So I hope that later I can go ahead and express it on the Venn diagram. But at this moment we don't have to. It's gonna take a little bit time over here to express all of this on the Venn diagram. I believe that we will learn that in section 2.4. Okay, but at this moment we don't have to. At this moment we don't have to display that on the Venn diagram. So next section we will. Okay. All right. Okay. All right. Now let's do some more practicing here. Okay. In the textbook, I think I forgot something. In the textbook, they also have another operation we don't want to miss. And this operation here, okay, this operation here we call that Cartesian product. Okay, Cartesian product. Okay. What is Cartesian product? It is a product between two sets, but it's a very special product. So given. Okay, given set A and B. Then Cartesian product between two sets A and B is notated as A cross B. Okay, A cross B. So this is a set. A cross B is also the set. So Cartesian product of two sets is also the set. And this set over here, we can get the element. The element is actually order pair. Okay, which element? Okay, elements are in order pair form. Order pair form. Okay, and the order pair form, you already know that is something like this. Okay, we have x component and y component, right? And A over here, A will be an element of set A, and B is an element of set B. Okay, so that's the definition. Now let me jump to the example. It's not really too bad with the example, believe me. Example. What if I have something like this? I have two sets. The set A is we have 1, 2, 3, and set B I have 4 and 5. Okay, so I can find this Cartesian product set. Okay, so this must be in order pair, and we're gonna pick one element of A, and we an element of B, and we're gonna make the order pair form out of it. So you will have 1, 4. Okay, that's the first element. Then we have 1, 5, second element, and 2, 4, 2, 5. Then we have, because A cross B, so we gotta do A first. Okay, so if you change the order, will be wrong. 2, 2, 4, 2, 5, and we have 3, 4. Okay, then we have 3, 5. Okay, 3, 4, 3, 4, 3, 5. There you go. Okay, so totally we have 3 times 2 is totally we have 6. So that is how you're gonna you will calculate. That's how you check whether or not you miss any element in this product set or not. Okay, because you have the cardinality over here is 3, and the cardinality over here is 2. So if you take 3 times 2, so the cardinality of A cross B will be 6. Okay, you take this. So make sure that you have 6. 1, 2, 3, 4, 5, 6. There you go. And sometimes we can, in many cases, we can go ahead do the Cartesian product by itself. So what if I have I want to find Cartesian product between B and B? Okay, then you're gonna have what we need. So you're gonna have 2 times 2, right? Will be 4. So we have 4, 4, 4, 4, 5. Then you have 5, 5, and 5, 4. There you go. So you can find Cartesian product by itself. Okay. Let's just make sure that I got it. All right. Okay, and you can find Cartesian product for this. Well, let me say you have 4 elements because it's 2 times 2. Okay. The last operation we can do on two finite set is we can find the cardinality of this the union between two sets. So on number 6 over here, okay, I'm gonna put cardinality of union set. Okay, so we know in the previous video the cardinality means the number of elements in the finite set. Now, what if I have I want to find the union between these sets, and I want to find the cardinality of the union between two sets, because you know that union of two sets is a set. So I want to find the cardinality of a union set. Okay, so the cardinality, we know that is notated by letter N, right? And I want to find cardinality between, for example, like some set between set A. Okay, let me erase this. So let me use different color right here. What if I have given two finite set? Okay, A and B. Okay, and I want to find cardinality of a set A union with set B. So cardinality of set A union set B will be equal to cardinality of A plus cardinality of set B and minus the cardinality of intersection set between A and B. Okay. Well, there's another easy way to find the cardinality of the union set. You just find the union set, then just calculate the number of elements in that union set. That's it. But this is the formula to find. It's just another method to find the cardinality of the union set. Okay, and it's good if you go ahead and memorize it. It's gonna help you a lot. Okay, now let me give you the example right here. Okay. Alright, what if I have something like this? Example. Okay. Alright, let's see. A campus blood drive survey, okay, indicated that 490 students are willing to donate blood. Okay, willing to donate blood. Okay, comma 340 students, okay, were willing to help serve a free breakfast. Willing to help serve a free breakfast. You just go ahead and write them down, okay? Because when you write them down, you remember, okay? To blood donor, you know, and 100 students were willing to donate blood. Okay. And serve breakfast. Serve breakfast. So look like that we have 120 students who willing to do both jobs, donate blood and serve breakfast at the same time. Okay. Question is, how many students were willing, okay, to donate blood or serve breakfast? Or serve breakfast. Well, the word "all" over here, the word "all" over here is very important because it helps us recognize right away that is union right over here. Okay, and the word "and" over here, it tells you that that's the intersection right over there, which is right over here. Okay. So we have 490 students. Just think about that. So the number of students willing to donate blood is considered as set A. So set A is actually have 490 students. Okay, and set B is actually 340 students. It's two different sets right there. Okay, and we know that set A intersect B is actually 120 students. So basically, you see the question give us every information already. So all you have to do is you just find the number of students between the number of students for the set, for the union set. Okay, A union B will be n A plus n B minus n of A intersecting B. So this is 490 plus 340 minus 120. Here you go. When we just give you the answer over here, just do a quick adding right here. Okay, just do a quick mathematics over here. It looks like the answer is 017 student. Okay, so over here they ask you how many students were willing to donate blood or serve breakfast. So we have 10 students willing to donate blood or serve breakfast. Okay, don't be confused between these two words. Okay, it's very important. So I circle that so that you recognize what part in the formula they give you and what part they asking you. Because sometimes they give you the union, the cardinality of the union, and they asking you for the cardinality of the intersection. Okay, it could be that way. So be careful. Okay, be careful. So this operation here is pretty easy. Okay, you don't have to do anything. You have to think much because everything is there already. You just go ahead and plug it in. So that's all you need to know for this formula. Nothing else. All right. Now I'm going to give you some more practicing problem. Because we already learned all the operation. We know the complement, we know the union, we know the intersection. So let's see we can do a problem that combine all the concepts we have learned so far. So I'm gonna put over here as a practicing problem. Okay, I believe this is so that's the second Roman. That's the first Roman, second Roman. So the third Roman. Okay, third Roman. Just put practicing example. Okay. Okay. Some example that we have to use all the concept we have learned so far. All right, so let's say that in this example, you the union a universal set, and the universal set over here is a finite set. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I also give you set A. Okay, set A is 1, 3, 7, 9. And I also give you set B is 3, 7, 8, 3, 7, 8, 10. Okay. So the question is, find A union B complement. Okay. And A complement intersect B complement. Okay. So let's see how we're gonna do this one. Okay. Okay, let's do A union B complement first. Okay. So A union B complement. So it means that you want to find the union between two set A and B. Then we take complement of that. Okay, that's what I mean. So first of all, I'm gonna go ahead and find a union B first. Alright, so A union B means we're gonna go ahead and find a union. You take everything between A and B, all different number or different elements. So we have 1, 3, 7, 8, 9, 10. So A and set A and set B over here, and number 3 is repeated, but we just need to write 1. Okay. Then from here we can find A union B complement. So this means all the elements that contained in this set, but is contained in the universal set, but it's not contained in this set. So we're gonna compare this to the universal set. So we have 1, 3, 7, 8, 9, 10. So it's not contained in. It's contained here, but not in content. Not contained. This will be 2, 4, 5, right? 6, I believe. So 7, 8, 9, 10, they already have it. So it will be 2, 4, 5, 6. All right. So this is the complement set of the union set. Okay, so we already got that. So I'm going to put it. Okay, so we finished part A. Now part B, we want to find the intersection between two complements. So we have to find a complement of A. Complement of A, which is what in the universal set, but it's not in A. So look like we have 2. We have 5. We have 6. 7 is in A. 8. Now we have it. So we have 10. Okay. And now we find a complement of B. Complement of B, which is in universal set, but not in B. Not in B. So we're gonna have 1, 2, 4, 5, 6, 7. They have it. 8. They have it. So 9. Okay. Then we're gonna go ahead and find intersection. So intersection between these two complements. So we're gonna find something in common between these two complement set right here. So we're gonna end up with 2, right? 2 in common. 5 in common. 5 in common. 2, 5, A hollows in B. Let me see. 3, 7, 8, 10. Complement of A is 2. I think I missed something. 1, So complement of A, I think I missed this as this complement of, we have number 4 over here. I'm sorry. So 2, 4, 5, 6, 8. Complement of 2, 4, 5, 6, 8, 10. Complement of B should be 1, 2, 4, 5, 6. Nice. Okay. So intersection will be 1, 2, 4. Okay. 5 and 6. Here you go. So you have to be careful, okay? Because if you miss the one of the elements, then the whole thing's wrong. Alright, so we have intersection between these two complements. Now, if you notice, so you see that the answer for part A and part B is the same, right? Yeah, right. Look at that. 2, 4, 5, 6. 2, 4, 5, 6. So what can we conclude out of this? We can conclude that. Very interesting information. We can conclude that if you want to find the complement of the union, okay, A union B complement, this is actually equal to intersection between two complements. It's very interesting, huh? Very interesting. Okay. Actually, this one over here, this formula right here, later on we call that the Morgan laws. This is one of the Morgan laws. The Morgan laws have another formula. If you want to find I want to find a complement of the intersection. Complement of intersection between two sets, then it gives you the union between two complements. Okay, very interesting. So this formula here, we call that the Morgan laws. I want to mention this law right away because you see that in the example, it's pretty obvious, and so you can see clearly that they are equal to each other. So this is the Morgan law. Okay, Morgan's law. Okay, and let me see. I can find another example. We're gonna find another example when we have to show this one or not. Actually, I can use this. I can use the same example here, but instead of finding a complement between union, I can find a complement of the intersection. Okay, let's see. We can show it so that the complement of the intersection set is the same as the union between two complements or not. Okay, let's see. So in the example 2 over here, I'm going to use the same information. Okay, so I have the universal set like this. I have A set and the B set. Now I want to find the intersection between A and B. Okay, so intersection between A and B over here is just 3 and 7. 3, 7. Then I find the complement of that intersection set. So in the complement will be what? Will be 1, 2, 4. This is complement which is not inside this but inside the universal. 5, 6, 8, 9, 10. Okay, that's a complement of intersection set. Then we find the complement of A. We already know the complement of A is this. We know the complement of B is this. So we can find the union of these two complements. So union between these two complements will what? So we're going to just go ahead and take all the various element over here. So we have 1, 2, 4, 5, 6, 8, 9, 10. Here you go. Look at this. Look at that. They all the same. They are the same. You see that? So it is one the same right over here. So the example 2 over here, I have over here is it's just verify. It's just verify that the statement right over here, the second De Morgan laws right here is true. That is true. We got it. Look at that. This set right here, the complement of intersection set and the union between two complement set is the same right here. Okay. So this information is very important. Okay, very important. Later on, you can use this this law over here directly, but this moment you don't have to. Okay, you just look at the universal set, find the complement, and so on and so on. It depends on what they want you to find. You can find it very easily. Okay. Now, what if I have in example 3? In example 3, I'm going to give you the Venn diagram. Okay. So I'm going to draw the Venn diagram here. Let's see, I can draw the beautiful Venn diagram here. Okay. And I will draw two sets. Okay. Okay, and I draw another one. Oops. Okay. Let me draw another set. Okay. It looks like this is not good, so let me draw that again. Oops. Okay. So I have two sets like this. And you see these two sets over here is overlapping each other. And I'm going to call this one a universal set. Okay, so this one is a universal set. Okay, it's a universal set here. And I call this set over here set A. And I call this set over here okay, I call this set over here is set A. And I call this set over here is set B. I just use different color. Okay, now set B. Now in set A, I have they have a pi. So let me use different color right here. I have pi, and I have E, and in set B over here, I have e to the pi I. Okay, then I have 10 to 100. Okay, there's 3 elements, and I have 2 raised to the e power. Okay, so I have 3 elements, this, and this, and it shares something in common. So they share a square root of 2 in common. Okay, a square root of 2 in common. They also share square root of -1 in common. Okay, so I had a picture like that. And the question is, we want to find A union B complement. Okay, that's part A. And part B is we want to find A intersect B complement. Okay, intersect B complement. And set C, question C, I want to find complement of A intersect B. And D, we want to find A union complement of A. There you go. Okay, that's what I'm asking you to find. Okay, so let's see how we're going to do this. Answer. Okay. So we want to find A union B complement. So first of all, we need to find A union B first. So A union B means we take everything. It doesn't matter. It's in A or B. It doesn't matter. We can take all different one. So oh, sorry. I think in the universal set they have another information. So in the universal set, I have in the universal set over here, I have pi e. What if I have something? How about some e to the square root of 2. There you go. I have that element. So that is considered as one element. Okay, it's one element, not two the element. So it's 1, 2, 2, 3. Okay. So we want to find A union B first. Okay. So A union B will be pi e square root of 2 square root of 1 e to the pi I 10 to the 100 2 to the e and e to the square root of 2. Alright, then from here we can find A union B complement. So you see that the universal set is everything. So A union B complement must be e to the square root of 2. Okay, very easy. Then we find A intersect B. A intersect B is also pretty obvious. It's right over here, square root of 2 and square root of -1. And from here we can get A intersecting B complement, which is everything except for this. So will be pi e e to the pi I 10 to the 100 2 to the e and e to the square root of 2. There you go. Pretty easy, huh? Pretty easy. Now for part C, I don't have space, so I'm gonna do over here. So part C, I don't want to jump to another page. So we want to find a complement of A. So I guess I have to jump to another page, even though I don't want to. So part C, we want to find a complement of A. So complement of A, which is everything not inside A, so it will be this is this and this, right? So square root of 2, square root of -1, square root of 2. No, not square root of 2, because square root of 2 is still inside A. So it will be e to the pi I. I'm sorry. So let's erase this. E to the pi I, comma 10 to 100, 2 to the e, 10 to 100, 2 to the e, and what else? And e to the square root of 2. Alright, so that is complement of A. Now we want to take union with B. So we know that B is what? B is this. B is this. Alright. So the union B has this. B is square root of 2, square root of -1. B is square root of 2, square root of -1, e to the pi I, 10 to 100, and 2 to the e. So that is your B, right? That's your B. not this, okay, because this is not okay. Then we're gonna go ahead find intersection. So intersection between these two. Okay, so we want to find element is in common. So what is that? So it will be e to the pi I, right? 10 to the 100, and 2 to the. There you go. That part C. And part D, what we want to find? Part D, we want to find A union B complement. So A is this. Okay, A is this. So A is pi E square root 2 square root negative 1. And complement of B. Complement of B will be pi E and E square root of 2. Complement of B is pi E square root of 2. Right. Then we're gonna go ahead find union. Okay, let's go ahead find union. So A union complement of B will be everything, right? So it will be pi E square root of 2 square root negative 1 and E to the square root of 2. There you go. Okay. Good. Right. Okay. So I'm gonna stop this video right here because that's all we need to know. So the most important part in this video is that you need to know how to find intersection, union. We're gonna learn how to display that on the using the Venn diagram very soon. In the next section. Okay, but that's all you need to know. Okay, cardinality between union set, union intersection, Cartesian product between two sets. So Cartesian product is a set. That's the most important thing you need to know. Intersection is also the set. Union is also the set. Complement is also a set. Intersection, union, difference between two sets is also a set. Okay, and Cartesian product is also a set. Okay, so please watch the video carefully. If you have any question, send a message through Canvas. Okay, if you don't understand anything, let me know. Okay, all right, that I will see you next time in the next video.